Yo, what's up, Welcome back. Today we're working on my x86 operating system. It's an operating system written in Rust, titled StreamOS, and it's like a toy operating system written for fun. We've got a little bit of a demo here. So when I launch it, this boots like a virtual machine QEMU, and it shows us like little demo of us playing like Brick Breaker, and we can like play this little game with either the mouse or the keyboard, which proves that we have like a graphics stack. Graphics stack is a little strong wording for what we have. We can draw to the screen, which in a real operating system this would be streaming, or a real PC this would be like writing to like VGA hardware. We have like a web server, so if I go to the IP address of the OS, like we see like hello from StreamOS, and I can say like something in here, and it'll send it back. And it'll log that it's like servicing those like requests on different CPUs. So that's showing that like we have like serial console output, which is like where we put our logs out. QEMU, the virtual machine, will like forward those serial logs to standard input and output. We have multi-CPU, right? We're like servicing these requests on different CPUs, and we have like enough of a like driver stack to get us to the point where we can talk to a browser. So we have like PCI so that we can talk to the Ethernet card, and the Ethernet card has like ARP and TCP and we have drivers for like address resolution and TCP and HTTP and stuff like that. We have USB support for the mouse in our game. There's a bug that happens occasionally specifically related to mouse we're gonna have to fix eventually, but not right now. And yeah, that's kind of where we're sitting at for like the OS as a whole. And what we're working on right now is this guy on the internet said it can't run Doom, or he said, can it run Doom? He was asking a question, just like a normal question, and you know, the being the way I am, I go, what no, it doesn't run Doom. Damn it, he's right. So what we're doing is we're pulling in the source code of Doom, and we're trying to run it in this operating system. So let's just quickly check out that branch because it's not functional, so I had to check out the master branch just to do the little demo. And what we did is we pulled out this like Doom generic project, which is like a C project that tries to make porting Doom to any operating system or like environment pretty straightforward. So, you know, its claim is like, hey, if you just implement these few functions, you'll be able to run Doom, and we'll handle like all of it's basically an abstraction layer, so that it runs like its event loop, and all you have to do is implement like a few little things. And we like pull this in, we compile it, and what we find is it turns out that like software uses standard libraries sometimes, right? So like if I go into like my like C program and I go like include, wow, what a perfect demo. I say like include standard input output, and I try to like do a printf. That's using like a function in the standard library. And because we're like running like a bare bones operating system, we've like made a compiler that doesn't have the standard library. And so we've had to go through and like look at like which library functions Doom is using and start implementing them. So here we've like stubbed out all of the different functions that they use and like basically crash our operating system in any case where we're hitting one that we haven't implemented yet. And what we've been spending like the last couple streams on is working on like the printf family of functions. So just because they happen to come first in initialization. So if I like run like cargo run, this will like build the operating system, package it up, boot the virtual machine, and we try to like initialize the Doom code. And give it a sec here. We've got like a million warnings. We'll ignore those for now. But what we should see is the operating system crash, and it says like not implemented, unimplemented to size for period. So this comes from some of our like printf parsing. So if we go into like our like little test C file, our printf right now only supports like if you write a printf with % signs directly. How do I say this? So printf, it supports a lot of like format specifiers, right? Like you can say like, I want, you know, to put leading zeros 5 times and maybe with a precision of 5, right? And if I pass in like a float here, let's just pass in like 0.3. I think if I compile this, gcc-o test, this should be %05f. if I run this, I see a bunch, like a 5 precision 0.30000. I thought that I was supposed to see leading as well. Maybe leading only works for %d. Just hold on. Yeah, okay, maybe leading only works for integers. I'm not 100% sure on this. But anyways, the point is, there's like a lot of stuff you can write before like the letter here that you put in your printf string that says like what the type is. And right now, my operating system only supports like %, then this guy. And so what this log is complaining about is essentially saying like, hey, somebody tried to put like a width specifier by putting a period in here, and you guys like don't fucking support that. So I think what we're gonna do is we're gonna start like trying to implement that, and then we'll just keep going, and hopefully we'll see where we get, right? We'll keep going through crashes of the operating system and trying to like heal bugs as they come up until we get to the point where Doom is up and running. So let's start by saying that we'll work on what should we call it? Printf format specifiers. Okay. So somewhere there's like a printf format specifiers like document. I think I saw one from Microsoft, which was pretty good. Here we go. Yeah, or maybe we can look at the printf on CPP reference as well. We'll kind of have both of these open and take a look. Okay. Does this guy have like the list of... I liked this guy better. Okay. So I guess we'll just start working through... maybe we'll start by kind of refactoring the way that we're parsing right now to have more support for like optional things. So hold on. Do I have this open somewhere? I must have just not closed it cleanly last time. Sorry, 1 sec. We open it, we open libc, and we delete the old thing. There we go. Okay. So the way we've like kind of like organized this code is when somebody calls printf from C, we handle the argument parsing of like variadic C functions from C, and we actually do the work of writing the string in Rust. So what we do is we have this like little loop that basically pulls open a like struct that has like the parser state in it, and he just like continually says like, hey, try to write out what you want to write. And what he'll say is hey, I need an argument now, and the argument has this like a size of like 4 or 8 depending on like what the type is, right? We parse the format string and we see like %d and we go, oh, the next argument has to be 4 bytes. And the reason you have to do that is because C variadic functions are pretty like dumb, I guess is the way to say it. So if you're like a function who takes in like, you know, like any, like say we'll take in like a number, and then we'll take in like extra shit. The way this works is basically if this is like your stack, like so you when you're like working with local variables, you put stuff on the stack. Arguments are passed on the stack in the x86C decal calling convention. You might like call the function with your stack pointer here. And what you're gonna do is you're just gonna like walk these arguments backwards. So if you have like 4 arguments, you're gonna say like, oh, let's look at the 4th one, the 3rd one, and the 2nd one, and then this one. And you're just gonna like push them on there. So like let's say we're moving down, then our stack pointer moves here, and we have like argument 4, 3, 2, 1. And so the compiler will like fill in for us. If we take like the address of the first guy, we'll know where 1 is, right? And we can just start saying like, okay, well, as we can just like move forward. We can like, well, we know that the 2nd argument is going to be like a certain offset, and the 3rd element is going to be a certain offset, and the 4th element is going to be a certain offset. But like how far to offset each time depends on the width of the type. And so what we do is we like check, sorry, where was I? Here. We basically ask, the Rust side will say, hey, I'm looking for an argument that has 4 bytes, and then we'll like move forward by that amount, and then we'll give that back to Rust, and then we'll do the thing again. Yeah, so that's all we're doing. So what are we trying to do now is we're trying to update our like our format parsing code. So I think that this is going to get a little bit more advanced. So I think what I want to do is I want to adjust the return type of this guy to say like maybe you're an optional return, and then we can put all of the formatting stuff in there. So I want this guy to return an option of this guy. And he's going to say, in the current state, I say, yep, you sure are something. Right now, we're assuming that we have we've like already parsed the percent symbol, and we're just moving forward by exactly 1. I want to like change that a little bit. So here, I want to say, if let some parsed format or parsed specifier, or maybe we just say specifier, is equal to parse format specifier self.format string. Then what we advance, I guess we just return the format. So we say ret equals format, specifier format to size like we had before. That's this guy. And then we break. And then in the other place we call this, which is here, we'll say specifier is this. And I guess we should, if we've asked for an argument, we should assume that we have an argument, like a format specifier that we're parsing. So we'll say let specifier is equal to match specifier. And if it's some thing, we continue with the thing. Otherwise, we just assert for now. This is like, we could do something smarter later, but for now we'll just say assert, panic, not a valid specifier. Because this is like on the side where we've already asked for an argument, we should know that we have a format specifier that we're trying to match it to. Okay. So everything else actually already looks good. And so now all we have to do is we have to like adjust this to like look for the percent sign. So we'll say if we dereference the format specifier, what do we do here? If the dereference thing is not equal to a percent symbol, we return none. This isn't just format specifier. Otherwise it is. And then we just have to start parsing like all of the optional things. So we'll say, we'll just start doing, I guess we'll start with the ones that we're hitting. So we're hitting the decimal point precision specification. Fuck it. We'll just do them all. So we'll say, let format or flag is equal to parse flag s. I guess here what we'll do is we'll move the pointer forward as we parse each individual piece, right? So we'll say s.add 1 here because we've already looked at the percent sign, and so we're good to continue. And we'll say here we'll actually reassign s, and we'll move forward the pointer as we check each thing, and so then we can either like not move it forward at all or move it forward depending on what we get. Then what's next? After the flag characters, we have the width. So we'll say parse width. Then we have the precision. So we'll just do this, parse precision. And then we'll do this stuff. So we'll say s type is, or format we'll call it, is we'll say parse format. There we go. And I guess just for consistency, we'll say let s. No, that's fine. That's fine. Okay, so now we actually have to like implement these functions. So we have a function. I guess we'll pull out all of these functions that we just said that we were going to write, and we'll slap them down here. And we'll quickly do a quick conversion. So we'll say delete these guys, put functions in front. These guys are all going to be pointers to the format string. So I think it's just a mute u8 or const u8, sorry. And parse flag is going to return a const u8 as well as a option of flag, which doesn't exist yet. Okay, the width is going to return a new pointer to like the rest of the format string, as well as a width, which will just be like a u32, I guess. Which it might not have, so we're just going to say option u32. The precision is going to return a const u8 as well as a option u32, right? We might say, hey, I only want it to be three decimal places, or we might say we want it to be a lot of decimal places. And the format is going to return a const u8 as well as a format. Option format. Oh, no, the format's not optional, so it's going to be guaranteed. Okay. So here, the format is going to be like this. This is actually supposed to be a const u8 on all of these guys. So let's just kind of throw those in. Okay, unimplemented on this guy, unimplemented on this guy. And here we're just going to look at the format character and return what we get. Oops, I made a mistake here. And then once we've gone through all of this, we're going to say that the let start s is equal to s. And the length that we get is going to be s minus start s, which I don't think we're actually not allowed to do. I think we have to do like s.offset from start s. There we go. Okay. So the idea here is that we like move through all of these guys. They advance the pointer to the point after their parsed thing. And then at the end, we check how far we moved, as well as the things that we got. Yeah. This guy will probably also have to have like precision, length, and leading car is a option of probably u8, I guess. Okay. I guess all of these guys are optional, actually. Cool. Cool. So here we'll just set them all to 0. Oops, I've used length twice here, so we'll say a leading or like format length, I guess we'll call it. And we'll call this like, oh, that's confusing. We'll call this like output length, and we'll call this format specifier length. And that might clear up the difference here. So format specifier length is what we had before. The leading car will be determined by flag, I guess. So we'll figure this out later. We'll start with none. Output length is none. And the precision is none. Okay. So I think with this the way it is, sorry, I have to write unsafe on all these guys as well. Let's stub these out in a way that nothing will happen. So this guy will always just return s none, i.e. we did nothing. And we'll do this for all three, and then hopefully we get to the same spot that we were before. Everything else should work the same way because we're still parsing the format string, but all of these other guys aren't implemented and we should still fail on them. And that way we can start compiling and then working forward with the compiler still helping us out a little bit. Probably the only thing we're missing now is somebody used the .length field before, and we just have to fix that. So this is a specifier dot format specifier length. That's what we're looking for. Okay, do we compile? No. What's he bitching about? An issue with VF printf. That's confusing. I didn't think I touched this at all. So here he's saying VF printf has the wrong type. Conflicting types were built in function. Expected this. And I guess we can just... Oh, sorry. This is... Fuck. I forgot to export my cross compiler. So we like the build script that we're running, we'll try to use the default compiler, which is GCC, but we're not compiling for our host system. We're just compiling for i686 elf GCC. There we go. So this should work. Or at least the fake libc compile. We should maybe we have compilers in the Rust code we were just writing, which we do. So we're missing. We fucked up a few things. The flag doesn't exist yet. We've converted an isize to usize, and we didn't finish a function. So 285. So this should say specifier, and then down here we forgot to return the right thing. So we should say s add 1. We've moved forward by 1, and the format is format. Okay, and we also hadn't implemented this flag type, so we'll just say enum flag for now, and figure that out later. Okay, what else is he bitching about? Expected usize found isize, so we'll just say this is a try into expect unexpected negative offset. There we go. Okay, so we're compiling again. We did forget to do reassign here. That warning saved us there, so we'll just say s equals s.1. And everything else is looking okay. All right. So if we run this now, I think we should just be in the same state where we see, how do I just say this? Yeah, we say not implemented toSize for period. And so now all we have to do is we have to start implementing parse precision. Maybe we should warn here and say parse width unimplemented. Parse flag unimplemented. Parse precision unimplemented. So that we get some sort of like indication that we fucked up. Let's just take a quick peek there. Oh, except our logs probably won't run because they only run on like async boundaries, which we won't hit here. So maybe we say print line instead, and these will get hit. Give it a sec. We should see... Oh, I'm an idiot. These are just going to log unconditionally, of course. Sorry, brain's melting. Okay, parse precision. So we say here, if the first character is not equal to a period, we return this. Otherwise, there's something to do. So otherwise, we move it forward by 1. And we just... what's the format specifier? He looks like dot and then like a number, right? So we just have to keep parsing while we see a digit. So we can just say while s is digit is ASCII digit s equals s dot add 1. And then at the end, we just return s and the digit. So we'll say, I guess we have to parse this thing as well. So we'll say that the num start is equal to the pointer here. And the number at the end, the number is s. So we can say let number is equal to core slice from pointer range. And the pointer range is just num start to s. And so we'll call this like a num string. And then we have to turn this into a number. So we'll say num is a u32 is equal to num s parse. Expect, and we'll say invalid number. We can assert here, one, because this is like scratch code that's going to go away eventually because like porting Doom to my operating system is like a fucking meme. But also because we should be guaranteed at this point that we have a valid number, right? Because we've only checked digits. Then we can say here that the return type is, we've now moved on to like the current s. And we return an option of sum with the number. Yo, have you missed anything? Nothing too crazy. We're just working on like, we've like kind of restructured our printf format parsing a little bit, and we're starting to stub out like working with precision and stuff, but we haven't made any like real progress since yesterday. Okay, so now that we've got this, we can say that the precision is precision. And otherwise, I think we're good. Now, if we have the precision, when we write it out, we should use it. So I wonder how we can handle that. I guess like what I've been doing so far is I've been using like Rust's format specifiers to handle this, but I think that we might have to get a little more clever with that. But we'll see. We'll see. I thought I wouldn't do precision as well, but I think it's important because if somebody's calling like sprintf to a buffer, they're like doing printf to a buffer, fixing the precision might actually affect the length of like the output, and they might have only allocated enough for a certain length, so we actually have to do it, unfortunately. Oh, parse only is implemented for string, so you have to convert it. So we say core stir from UTF-8 unchecked is this. And then does it work? Error? What's he bitching about now? From pointer range is an unstable library feature, so we have to do from raw parts, and we'll say the start is num start, and the length is s.offset from num start try into dot expect invalid negative range. All right, he doesn't like that we're assigning to a mutable thing, so we just tack on a mute here. Boom. Pretty sure you could just check all do generic 2, see if that buffer and precision problem ever happens. I think like I checked it enough to notice that they did call it with sprintf. So, whatever that means. Okay. Not implemented. Unimplemented toSize for what the fuck is this? That seems like a bug. Big bug here. Well, not big bug, but that's looks problematic. So I guess what we should do is double check that we're not doing something fucking stupid. So I guess what we can look at is we can look for who's actually using the format specifier. So we can say percent dot and look for who's doing that. So we see here and here a percent dot 2 and a percent dot 3. I guess we can just start printing out. We can try to find where we are in here. So this is a load unload data. How do I want to handle this? How do I want to handle this? It would be nice if we get GDB working. So last time we found that if we spam the inner, like, GDB has been kind of flaky on us recently, but we found that there's like a way to kick it into the right state by spamming interrupts manually on the keyboard first. I hope I don't have to resort to that again today, but we'll see. So let's pop up another shell that we can run GDB in. And you might ask, like, what the hell does running GDB mean when you're running like a whole operating system? And it turns out that QEMU just implements a GDB server. So he can like he has all the information as like the virtual machine to tell GDB like where in the code you are, like where's my instruction pointer, and where's like what does my stack look like, what does my memory look like. And so you can actually just run GDB on your OS, even though your OS doesn't have like GDB support built in like Linux does. So oops, I forgot to spam Control-C, so we'll try that again. So I found that like doing this somehow improves behavior, but not really sure why. But yeah, see, now all of a sudden I've got a breakpoint in my panic and working. So we are in a function iBind joystick variables. Oh, that's interesting. So whatever we did broke some of the earlier parsing code. So this used to work, and then whenever we implemented our parse precision, it fucking got broken. So here, if we go back to precision is none, and we don't run parse precision, we actually probably get past that point again. Yeah, okay, so, because I know, oopsies, I pressed some button that fucks up my tmux, I don't know what button that is, just when we restart. I was wondering if the non-parser crate would be a good fit for printf format settings. It could be. I'm of the opinion that parser crates are overkill. Because you have to make, like, this, like, you use this, like, weird language that you have to write, and it's like, is it even, like, easier? Like, it is in some cases for something complex, but for something like this, it's so simple that we should be able to just, like, bang it out ourselves. Okay, so, sorry, where was I? I know that this period parsing comes after the joystick stuff because we've already hit the joystick stuff before. So we can be pretty confident that we've just done something wrong here, specifically with advancing the pointer. And that's because we just didn't advance the pointer. Here, we need to say that, oh no, we did. So we added, every time we found a digit, we incremented it by 1. But only if we found a period. So really, in the case of like the joystick parsing, we should be hitting this path. So let's try printing here, returning early. And here we'll say not returning early. And we should see that everybody says returning early before we get there. Okay. So the fact that there are some not returning earlies is concerning. Let's double check. Okay, parse precision. So if it's not a %, we return none. Otherwise, we increment by 1. These guys do nothing. And so here, this should also do nothing. We should say we found a period and we return early. But then why am I seeing like not returning early sometimes? Oh, maybe the joystick stuff is happening again. Let's see. It unimplemented toSize for 2. Again, weird. Weird. And just double checking again that it is in fact the precision parsing stuff that's causing this weird bug. Yeah, okay. So the fact that saying unimplemented for 2 makes me think that we're not advancing correctly on these. So maybe we can print out, like, maybe we should print everything between the beginning and where we got to here. So, let's think about this. Let's print out the parsed, like the string that we get from this guy. So, which I think we can just do this. So we'll say print line found precision of this. Found precision of 8. Okay. Maybe we should start him from... I want to see like the whole thing. So we'll say let format start or precision start is equal to s beginning. Here we'll say precision string is equal to precision start with the length offset from precision start. I just want to make sure that that's like sane. Which it doesn't. Oh, I'm logging the wrong string. Logging the wrong string. So what do we see here? Found precision of .8. Okay, so that seems reasonable. Can we maybe find out if there's a .8 anywhere in the code? Which we should see like %.8. Okay. So that's interesting. So we're parsing the format string correctly, but then we're getting this like unimplemented two size for two, which is weird. Oh, maybe we're just making it farther and someone else is trying to like let's think. Maybe what we should do is we should print out the whole format string, the original format string, when this fails. Because then we can like find where in the code we're supposed to be a little easier. That's what we'll do. I like that. So here we'll say original format string is a const u8. Nothing else changes. When we construct our printf writers, we just copy the original pointer. So say original format string. Oopsies. Sorry, one sec. Original format string is format string. And we have to do the same thing here. So we say original format string is format string. And everything else I think stays the same. So now when we crash on unimplemented, we can say, here's the format string. And we say core stir from UTF-8 uncheck. Fuck. We have to get a little crazier here. So we say let format string is equal to we actually can't log that here because we don't have the information we need. So instead what we'll do is we'll return a error here. I guess we'll just say the error could be, we don't really care what the error is. Here we'll say ret is equal to this and wrap the ret in OK. Here we'll just return an error. And then whoever's calling this guy here, we can say match this. And if we get OK value, we just continue with the value. Otherwise, we see error. We don't really care what the error is. We can say panic unhandled to size in. And we'll just write the format string in error. So say format string. And we can maybe even say position this. So we'll, where the position is the position. Now I just have to figure out how to make those format strings. We'll say let format string is equal to the original format string, but turned into a C string. For fi c str from pointer, I think is what it's called. And the position is equal to the current position in our thing offset from the original format string. Because we're like advancing our format string as we move forward. We're like basically as we like parse, we literally chop off the beginning. Nobody's bitching, which is good. Can I run that? Nope. It looks like my language server is not bitching as much as I want it to be. So this should be C-string. C-string cannot be formatted with the default formatter. So can I maybe... I wonder what happens if I debug printed. Or maybe I say to stir and unwrap it for now. Since this is just scratch and throwaway code. Something has const i8 but should be const u8. Oh, because this guy needs to be const i8 because it's signed versus unsigned. Doesn't really matter. They can be cast between each other fine. Okay. So on handled to size in joystick physical button on it. Position big ass number, right? That's fucked up. Have I fucked something up here? Self.format string offset from original format string. How the fuck did we get so far away? Look at that. 11028 is crazy. Right? Like, this is only like 15 characters long. So somewhere, I wonder if it's this guy. Right? Maybe we're advancing just like way too far because our while loop is wrong. Found precision of dot. Okay. Oh no, because that guy shows that he's only. When we did that before, he only showed .8, which seems reasonable. So who else is advancing this guy? Not parse width, not parse leg. Parse format is only moving him one forward. Oh, are we not breaking on null terminator, maybe? No, here we are. If we can write null, we behave as normal. Oh, but I guess if cars equals 0 and not self-write null, we break. And we should return 0 here, which tells it to stop. I'm missing something. Maybe what we'll do here is we'll just, at each advance, we will print the position in the format string we are. And maybe that'll give some clues. Print line. Format string offset is pause. And let's just kind of see what that tells us. Yeah, so we're just like not like exiting correctly, which is fucked up. So, maybe it's something to do with the format specifier being at the very end of the thing. We should actually check if we're at the null terminator before we check if we're at the format specifier. Maybe that's the problem? Is it like we're just going past the end because there happens to be a percent in memory after? No. Nope. Maybe we can... You aren't exiting if you find null terminator but you aren't printing it? I'm pretty sure I am. Pretty sure. Because in that case, ret should be 0. And in my printf loop, I break if the returned thing is 0. I say like we're done. Because like that means that there's no more arguments to push in. So I should be exiting, but I could be wrong. Pause 11028. What else could be causing this? Thinking. Oh, I'm not breaking this loop. Yeah. So, this guy should actually be like this. And down here, okay, so if cars equals 0 and self.write null, we do this, then break. Else, if cars equals 0, we break. Else, we just increment this guy. There we go. Good catch. That's crazy that this has been working at all then. Yeah, okay. Nice. Okay, yeah, we're a lot closer now. That's pretty sick. Pretty sick. Unknown configuration variable. Key message player 1 tick phi. Key multi-message. Key multi-message player 1. So here they're trying to say key multi-message player %i plus 1. And we are not null terminating properly still. It looks like. Right? Because we're just continuing on in memory to 1 tick phi 9, which is like, what the fuck, why? So if car is equal to 0, and self not right null. What am I missing? So we iterate we loop over these guys. We check what the thing is. We say if he's 0, right null. I guess it's because maybe something to do with the %i being right at the end. Maybe we push the argument. After we push the argument, what do? We should advance the current location by however long we thought the format specifier was. Let's print line advancing by this guy. And what we should see is we should see that he's advancing by 2. In the case of seeing %i. And we are seeing advancing by 2 everywhere, which is good. Oh, wait. But here we're seeing unknown configuration variable before that. So I guess here we should check what we got for key message player. Let's think about this. Thinking about this. So here in mBind variable, I think we're printing that we didn't have the right thing. But in that case, when we're seeing this advancing by 2 is like reasonable. Sorry, I'm not making much sense because I'm lost. I am lost. So it makes sense we need to like break down the problem. We need to think about where could this be going wrong. And so clearly it's related to either null terminator parsing or printf parsing. And so I guess what we should really do is we can easily make our own test here. So in fake libc, we could call test printf, and here we should just test exactly what they're sending us, and then we can start like looking at the problem. So here we can look at where the fuck we just were, this guy, and we should just call this. So we can call it with what he's doing. He's got a car name of 32. Like this. And we should sn printf into name, size of name, key multiplier this, and we'll just punch in a 3 or something. And this should give us, if we then run in our main, we said instead of saying doom generic create, we just call test printf. We should see a problem. We should see the same problem. Oops. We have sn printf is unimplemented, but vsn printf I think is not. So we can oh boy. I guess we just implement this. We say sn printf is the same as va list args, va start args format. So the first thing here is this is the format here. So you can name him. This is the size. This is the buffer. Yep. So here we say that the list is this VA list args, which is like the variadic argument parsing. Then we can say v_sn printf, which is implemented, buff size format args, and va and args. And so now you should see. Okay, cool. We compile now. And so now we should be able to say printf and just printf back what we got. So we can say %s name. And we should see garbage trailing off the end of it. Yeah, look, key message player 3 followed by key message player 3 again. Hold on. Let's check this again. Okay, do I call test printf twice? Oh, I do. Okay, so that's actually behaving sanely. But what if we initialize this with ones? I think you can just do equals 1 like this, and I think that should auto-repeat itself. If not, I might just have to memset it. That's fine too. Maybe I memset. I can't remember the API for memset, so forgive me. Man memset. He is the pointer, the character, and the size that I want to set. So this is 32. And maybe I'll like put in some dots or something. Let's try running that and see if we now see the same failure. Okay. So that's, oh, we need to set the last byte to a 0. Oh, wait, okay, hold on. No, not hold on. I don't know where this is coming from. I don't know why this is failing. So we'll do the same thing we did before. We'll pop open GDB and try to use that to tell us where we're panicking. And we probably have to do the same thing where I just like hit the Control-C button a few times. And backtrace. So this is coming on libc puts. Oh. Oh, okay. Hold on. In test printf, we're calling puts because the GCC is doing some like dumb shit here, where it compiles out my things. I'll just say, fuck. It's like optimizing the fact that this is just a string, right? And it's saying like, oh, %sn, that means puts, which I don't want. So let's try this again. And we'll type source run.gdb and we'll hit Control-C a few times. Oopsies, I fucked that up somehow. Source run.gdb. What is it complaining about? Terminated via GDB string. I've never seen that before. Okay, there we go. Oh, yeah, okay, sick. So we are seeing the same behavior now, where there's no null terminator being written correctly. And so now we can start trying to like debug this a little bit more cleanly. So maybe we can say in fake libc, in our test printf, we can just say if name, if we don't see a if strcomp of, can you run CC without optimization so it doesn't optimize your prints into puts? That's a good question. I think that I actually am running with O0, so it is kind of surprising that it's doing that. Yeah, I don't really know why. It is confusing though. So I wonder, how do we want to like debug this now? we can start going into our fake or into our libc.rs implementation. And now we can just start like bisecting, I guess, where the problem might be. Or we can start doing some more like intensive logging because we know exactly what we should be printing now. So maybe here we'll just print line character that we see. And let's see what that tells us. Oops, I don't want to run with GDB anymore. I want to run without GDB and just use some logs. So key multi-message layer %. Then he sees a space. Test %. Key multi. Wait, why am I only seeing this? I'm confused about. Shouldn't I be seeing this twice? Once for the strncpy and once for the printf. This could be a bug here. No, that doesn't look right. And is this where I want to be printing? I guess. Maybe I want to print this as a U8, and here we can say first car or found car this guy. And maybe down here, I print him as a size. We say print line size of format string is this. Okay, maybe that'll give us some clues. So the size of format string is 19, size of format string 0. So that actually seems pretty reasonable. Oh, wait, size of format string 0. It should be 1 when we see the null after the %i, right? Because what we're seeing is like this part, which I assume is 19 characters. Then we're seeing the % symbol and the format string. And then we should be seeing the null terminator. Which is interesting. I wonder if the strncpy is getting compiled into something fucking stupid too. I guess we should check that. So here we should see that our strncpy is in fact calling new with buff. So we just like print line real quick. This is being called. Just to double check. And we are saying this is being called. And can we double check that the printf is also being called? We'll just also say this is being called too. This is being called. This is being called too. So this is the printing of the actual thing. And then this guy, this is the part I'm looking at. So the fact that we found character 0 and the size of the format string is 0 is the interesting part. We should be seeing that the size of the format string is 1 because we're trying to write it out. So that's where the bug is. Here somewhere. So we should be seeing that char is 0 and, oh fuck, this condition's just inverted. God damn it. God damn it. I hate, dude, writing like simple bugs like that eats so much fucking time, dude. Yeah, see, now we're seeing key multi-message player found 2, 3. God damn, just like so like minor mistakes like that can just absolutely murder your like performance. God damn. Not performance of like the code, performance of you as a human. There we go. Okay, so we just got a lot farther. And so I just want to go back into my libc implementation and remove some of these print lines that are unnecessary. And now let's see where we're crashing. Let's go. Fucking finally. That's sick. So I think that maybe that segment might be completed. We're at least past hell. I guess we should double check. Did I actually start using the precision at all? Precision, he's set here as precision. We should set him. And here when we write floats, we should use them. But there actually are no floats written ever, which is kind of interesting. Also, it doesn't seem to be causing any major problems. So I guess just parsing the precision and not actually using it is enough for now. I guess. That's kind of odd. Or we actually were only getting to a precision modifier because of that bug where we were not getting out at the right time. That's actually also very possible. Okay. So we're now at fake libc, strncpy unimplemented. And this is just, we're back into like easy mode. So we go into our Rust implementations here. We can look for memcopy, and we'll just put like strncpy around here. Is there a there's strlen. We'll just put strncpy here as well. Strncpy. And he has a destination, a source, and a maximum length. So DSN, those are the right things. And he returns nothing. Cool. So we can assume that the length is just going to be either the length to the null terminator in the string, or the size. So we can say s.find iter.position. No, we can't iterate over a pointer. So we say strlen s. We'll say that the copy length is either the str length of the string, or if that's too long, size of n. So we're going to take the smaller of the two. And then we just say memcopy ds copylen. And he's not supposed to return anything, so we do that. And arguments of this function are incorrect, so what's he bitching about now? Fine, we'll make him an i8, I guess, as const i8. Cargo check. We build, cargo run. Let's see it. Oh, okay, nice. Nice. So we're getting farther now. That strncpy looks kind of reasonable. This saving config in .9-default is almost certainly not right. Where is that .9 coming from? Who knows? I guess we should look at that just because it's going to bother me. It's going to come back to bite us. Saving config in %s doom defaults file name. Where does this guy come from? Doom defaults file name is equal to my argv I plus 1. That seems sketchy. Oh, I see. Otherwise, we have mstring join. So it's probably here. We'll just say here. We'll just do a quick check. Printf string join path. And here we'll say argument path. And we'll just see which one of those we're taking. String join path. Yep. Okay, so that makes sense. So we're going here, and we're string joining config-dir and default extra config. So we'll just printf config-dir and default extra config. And see what we get. Dun, 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 dun. saving config in this guy, and we have dot and doom generic doom dot config. Oh, this is just after. Sorry, the printf is coming from here. I was trying to log this. Made a quick mistake. Okay, so he's saying dot and default config, saving config in dot default dot config. That's weird that printing these things here fixed it. Very odd. Maybe m string join is broken. So let's see what he's calling. Was it something that we just implemented? malloc string copy. So it does look suspiciously like our string copy is maybe broken. M string copy is this guy, and he calls strncpy. It does seem suspiciously like we might have made a bug here. Doom defaults file name. Let's maybe put a /n on there. Just to see. Okay. Weird that printing here is changing anything. Yeah, that's so odd. Very, very odd. It must be, well, let's just like sanity check my stir and copy implementation. So he has the strlen of this guy or n. So we're seeing like an offset from like the default thing. We're seeing like 2 character offset from what we were supposed to see, right? We were supposed to see dot default config, and we're seeing like a 9 dash come in. We have memcopy dest source length. We're either checking the strlen. Oh, we probably need strlen +1. Because we want to copy the null terminator as well. Yeah. That's probably it. Yeah, there we go. Quick fix there. Sweet. So now we're getting strdup unimplemented. So what's that supposed to do? Strdup. Looks like he just mallocs and memcopies maybe. Man strdup. What is he supposed to do? Function returns a pointer to a new string which is duplicate of string s. Is obtained with malloc and should be freed with free. All right. So in our libc implementation, we can make one of these guys, and we'll put them next to the strncpy because that's like string stuff. This is a no mangled pub unsafe extern C function so that it can interrupt with C correctly. We say function strdup. He takes in the input string, which is a const i8. He returns another const or mute i8, I guess. And all he does is he finds the size of it, I guess. Strlen s let length is equal to strlen s +1 again because we have to get the null terminator. And then we malloc length. We return ret as mute i8 because he was like a u8, he has to be cast to an i8. And then all we have to do here is copy the string in. So we just say str copy. I guess we'll just mem copy. The destination is ret, the source is s, and the copy length is length. Easy. And this guy just needs a quick as const u8. Solid. Let's run it. There's an error somewhere, so let's just quickly sort that out. Multiple definitions of strdup, so we have to delete the one that just crashes our thing. So we go to fake libc, and we look for strdup, and we just like nuke that guy. He's gone. No more of him. Star unimplemented. Okay. I guess probably somewhere I just accidentally didn't fill in the right function name. Yes, this is fopen. Is there any of the other ones? Hopefully he says fopen unimplemented. Cool. Cool. So I forget what we were doing in here, but now we're at around like an hour 10 into stream, and we're looking at fopen. Okay, so what I was thinking for file system is I was thinking that we would have like a virtual file system where we can basically like implement it as like a hash map internally. And so when we fopen, we just like add a buffer to the file system at that path. And yeah, then like all file operations just work on that like bucket of bytes. Like a vector or something. So I'm actually gonna just take a quick little break. I'll be back in a minute, but when we come back, we'll start working on like that type of thing. One sec. And we're back. Okay. So we need to implement fopen. So I think that we're probably gonna have to have in our libc thing. Sorry, let me close this other window. We can have like struct fake file system. And inside him, he's gonna have like files is like a hash map. Oopsies, crashed my language server again. Love that. Okay, inside here is going to be a hash map of like paths, I guess. So like string. I guess using path buff is like more rusty, but string is more CE. I guess maybe even like vec u8 is like the most C-like. So he's going to have like a hash map of vec u8 to I guess another vec u8. I guess. So why is that? I guess we'll use like type test here. So we'll say type fake path is a vec u8, and another type fake file is also a vec u8. That makes my life a little bit easier. And so here, then we can say fake path to fake file, and that looks like a more reasonable thing to put in here. You can use box u8 because you don't have to resize the file name. That's true. I think that makes my life a little bit more complex. Maybe box u8 for, yeah. Because I think then you have to deal with like conversion from vec to box in order to get this guy. But yeah, you're right. That seems fine and like reasonable. Okay, so then what we're gonna have to do is we're gonna have like a static implementation of this guy. So we're gonna say like static fs, or file system, I guess, is a mutex protected, which I think we actually can't use the mutex here because we're not in async code. So instead, we're just gonna like use a spin lock, which isn't great, right? We're gonna say that now, right? Spin locking every time you do a file open is probably not great if you have like actual multiple threads. But I think that we only have one thread, so putting a spin lock here is fine. We're never gonna collide, and we're gonna spin lock around a fake file system, and we can say this is fake. We'll say impl fake file system, and we need to make a new function. It's going to be const because we're constructing a static with it. Const function new, and we'll say this returns a fake file system. Right, and we just say fake file system. I've got an extra S here somewhere. File system, here we go. Fake file system, and the files are just default constructed. Sick. And then here we can just say that our file system is spin lock, new, fake file system, new. And we just have to add fake spin lock to our import. So we'll use core, not core, create, util, spin lock. He doesn't like that I lowercase my spin lock. Cool. And we can't call a non-const function hash brown new, really? Is this not default? Is this not const? Why the fuck not? We don't have to do any allocations to make this guy. Oh, that's annoying. So I guess we just wrap him in options so that he can be const. Black. Okay. Once cell I think doesn't exist here. We can check. Once cell. Cell that can only be written to only once. Oh, okay. I thought that this wasn't available to me for some reason. Maybe I can't use this in static namespace. I'm pretty sure I've tried this before. Hash map new isn't const because of the hasher. Oh, okay, that makes sense. Once cells new as of 1.70 Rust. Is that recent? Rust. What am I on? Okay, relatively new. Yeah, we can try one cell here. You've piqued my curiosity. Which comes from core. So it's core cell once cell. And so here, do I just say once cell new or something? Hey, that's kind of neat. That's nice. I like that. Okay. Okay. So cargo check. Do we still compile? Looks like we do. And now we need to start looking at like what does an fopen do? Well, first let's pull in the fopen definition. So we'll write this file and we'll go back to libc and let's see what this guy does. So we need to convert him into Rust function, which means we put function here. He returns a file star, which in our case is a mute file, I think is what we call this guy. Yeah. He has multiple inputs, so let's check real quick what those are supposed to be. So if we look at fopen, we have the path name and the restriction, the mode. So here we have path is a const u8 and mode is also a const u8. Presumably we can ignore mode. Probably, right? Because anybody who's like opening with something with like read-write permissions or like write-only permissions and then trying to read it will already crash. And so we can just assume that we don't give a shit. That's going to be my thought for now. And what we're going to do is we're going to look at the file system and we're going to lock it. And is this guy a spin lock guard? Yep. And so then we can just say, we can start doing stuff. So we can say like fs open path. Cool. So we can have like a function open, which takes itself by immutable reference. No, mutable reference. We can be mutable here. Nice. And he takes in a path, which is a const u8. I guess really here we should be in like Rust mode. So maybe we should just take in the box u8 here. Right, we can do like C to Rust conversion in like the C bindings. That kind of makes sense. And he needs to return a, I guess a file reference. And this guy can be static. I guess, no, he'll be tied to the lifetime of himself, which happens to be static, and that's okay. Unimplemented, of course. We have to figure out what we want to do there. And here we can say we return this guy. So we say, first we need to convert the path into a box. You could use asref u8 for path. I think I want to force the caller to put the button. Yeah, I mean, I'm okay with doing it this way because I have to do the copying into a box somewhere, and doing it here seems reasonable. I'd probably do asref u8 somewhere else, but I think that's fine. We'll say here that the path, how do I want to call this? Path, we'll just rename it, that's fine, is equal to, I guess we need like the cstr of the path. So we'll say let path is equal to str core fi cstr from pointer path to str expect invalid path. So this is now a str as bytes to vec to box to, what was it? Something about boxed into box slice. What a sick, what a function call. What a function call. And this needs to be unsafe function. And here we can say as mute file, this guy returns a mutable reference so that cast works out. This needs to be mutable, and this needs to be no mangle and pub unsafe function. What was pub unsafe extrinc function? Woo! Okay. So, Jesus Christ. Look, God. Ugly, 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 but that's okay. Okay, so our open function, what's he gonna do? Here we're gonna like put the, first we need to make sure that the files is initialized. So we'll make a function files that takes in mutable self and returns the mutable hash map fake path fake file. This is kind of fucked up a little bit because it kind of makes, this kind of like steals the whole thing of self as mutable reference, which means that if there were other fields in here, we wouldn't be able to use them while we were borrowing this, but that's okay because he's the only field. And he's going to say self.files, and we have to like look at the API of one cell. So get or init, and we just have to j hash map new, which I guess we can probably pass in like this. Like this. And he returns a immutable reference. I want like a mutable reference. Is there no get or init mute? Okay, so then we just say self.files get mute. Fine. So he expected this, but he got that. Those look like the fucking same. Those two types looked identical to me, so let's look here. Maybe it'll look clearer. Oh, because it's an option. Expect invalid files uninitialized. And it should be guaranteed to be initialized because we literally just initialized it. Okay, so then we say self.files. And what are we going to do with these? We're going to say I guess if the path is there, then we'll get it, or we'll insert nothing. So we'll say files, entry, path, or default. So this is what we get back. We get the file as the default thing, and then we have to wrap this in like the enum. So our enum right now only supports standard as a file, but we can just say like file. And I guess, do we like store the bucket of bytes in here? It might need a little bit more than that, right? We might need to like have like a cursor or something for when somebody calls fwrite later. We need to know where in the file we are. But for now, we'll just return the bucket of bytes. So we can say this is a... Ooh, what is this going to be? A mute? Like a mutable vector of U8? We actually probably should actually store the files in spinlocks as well. Because you could have multiple people with file pointers trying to write to them at the same time. So this guy gets a I guess he's gonna be a pointer because we don't have like lifetimes associated with them, or he could be a static. When he comes back, he'll still be this. He'll have like the same bytes. That seems reasonable. So he'll be static thing. Oh, but we can't just return a reference to him because he's stored in like a hash map. And when I like add things to the hash map, he might actually like move around. Which means that the guys in the hash map actually have to be a box spin lock. Which means that the spin locked thing, the vector, will actually be stored at a fixed memory location, which makes this safe to move around. So we'll call this fake file again. And here we can then say you have a static reference to a vec u8. Okay, so there's no or default anymore. So we'll say or insert with, and we take a function in here and we just say what? Box new spin lock new vec new. Gross, but it is what it is. And then we can return file, file, file. Sick. Consider borrowing mutably here. Oh, that's annoying. So we actually can't... We need like a static memory location for the file too, because the API of fopen returns a file pointer. But I guess we could just leak it. So let's do that. We'll return the file. He doesn't like this for some reason, because we need dereference. And then pull this up. What the fuck? File. He wants a static vec u8. Oh, he should be a static spin lock. Vec u8. There we go. Which means this will now work, but he can't implement partial EQ anymore, which is annoying. So that means all of our assert EQs on files won't work anymore. Here's what we'll do instead. We'll just implement EQ shittily. Impl core ops EQ. No? Core, where's the EQ implementation? It's supposed to be core comp EQ for file. And I guess we need partial EQ actually first. And we can say that EQ is what do we do here? We say match self other, and if we get RHS is supposed to be guaranteed to be the same type, I think. Type RHS equal to, oh, maybe I have to put partial EQ. Yeah, file for a file. And here we're going to say that we want, if we have stood out, we return true. Otherwise, we return false. Easy, hacky implementation. And can I derive EQ given that I have a partial EQ implementation? Cannot find RHS in the scope, so this should be file. Stood out is bound more than once, so we should say file stood out. File stood out. And I guess here we need to manually implement EQ still. Hey, finally caught one of your streams. Question: why did you end up doing the dual design for the printf implementation? Why not iterate the pointer in unsafe for us? Sorry if it was already asked. Oh, it's just because technically I view how do I say this? So in fake libc, if we look at the vfn printf, the v style functions, these guys as part of their function API, they have like a list as this like VA list type as part of their arguments. And I could have defined this VA list type in Rust and iterated in there. I definitely could have done that. But I thought that like, because the like VA style functions are implemented in like stood arg.h, and they have to be macros because some of their parameters are like type parameters or like names of parameters and stuff. I wanted like to handle the variadic argument stuff in C, just because like then all of like if I change the implementation of these, I don't have to like worry about that on the Rust side. It just seemed more reasonable to me at the time. I think that you're right though, that I could have like pulled the stack pointer in Rust and like iterated back on there, assuming C decl calling convention. That definitely could have been done. It just felt like a more like cleaner implementation this way to me. That's all. That's all. Okay. Spinlock doesn't implement debug, so I guess we'll just derive debug on him. Oh, and somebody else asked if I should use arc, spinlock, vacuate, and I think I don't have to do that because the files, I'm not planning on ever removing the files from this like fake file system. Once they've added, they live there forever is my thought. But I guess you could have multiple people fopen it. Like, it depends on if I ever implement like a delete, which I think I won't. Okay, do I compile now? I might. Error. What's it bitching about? Invalid cast because I need to leak this guy. There we go. Do I have to like box leak like this? Box new. There we go. Okay, so there's some lifetime issues here. So what's it complaining about? Borrow data escapes method because file is an and mute. Can I just like and star it? Oh, I see, because I've said that this has to be static, which it's just not. I'm just gonna fix this for now by making this a pointer, which I know is not the Rust way to handle this, but I don't care. As an alternative, you could look at the Rust C variadic feature. Let's take a look at that, just out of curiosity. C variadic Rust. I actually didn't look at this at all, ever. Oh, this is like an unstable feature. I see. And you can just pass in args and, oh, that's kind of nice. I should have done that. That looks way better than what I did. That looks nicer. But I guess I still had to implement the C side no matter what, because the variadic argument parsing stuff was like important. And I still don't know how I would handle like a VA list input. Interesting though. Very interesting. Okay, so if I make this a pointer, I can't store it in static namespace, which is like fucking annoying. I guess I can though if I just say impl sync for file, and I think it's unsafe impl sync for file, then this probably will allow me to do that. Error. What's it bitching about? Yo, what's up, what's up? Is C variadic type safe? I don't see how it could be. I don't think it can be. I'm assuming no. Like, I think that what they did there in this example is you tell it the size and you just have to fucking be right. That's what I'm assuming, but this is the first time looking at it, so don't trust me. So here it's bitching that the arguments here are incorrect, which means I just do a, like, star and, or and star, just star, double star and. This is how you're supposed to code. Just randomly type shit until it works. Looks like you got to the IO part of libc. Yeah, that's where we're at. Okay, so now we have a file pointer. Cool. And probably if I run now, I think that we should get past the fopen, and presumably somebody's going to try to fwrite, and that's going to, like, fucking fail. Oh. fclose unimplemented. Oh. Shit. I guess, in our case, doom2.wad doesn't exist. So we actually do have to parse the modes. Because if they don't have, like, the create flag in the fopen thing, so if they, like... Okay, let's pull up an example. So if I called, like, fopen test.c, and I have, like, create flag here, I think, that means it'll, like, create the file. But if I just have test.c read, and test.c doesn't exist, this should fail, if I remember correctly. So here, let's see, the modes are read, write, append. Oh, there's no create mode in this. I'm confusing that with something else. Maybe it's if I don't have the write flag. Oh, here, they are saying that they have an extension for create. So presumably somebody here is going to tell me that we return an error if we don't have the file. Specified for open. Ugh, gross. Reads and writes being blah 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 blah. Jesus. Okay. I guess we'll parse the open flag. Yeah, okay. We actually do have to keep track of this. So we'll say let mode stir is equal to c stir core ffi c stir from pointer mode. And we'll make this an I8 so that parsing works better. Then we'll say as stir. Nope. Let mode stir is mode stir to stir. Expect invalid mode string for fopen. And here we should then, when we create open, we can pass in create a we'll pass in a create boolean. That's really all we care about. And we can say if create, or maybe we'll say write. We return this. Else we return none. So this has to be failable now. So he has an option file. And here he returns some file. Otherwise he returns none. Okay. Now here we can say match fs open path. And if we get a file, say some f, we return this shit show. And if we get none, we return a null pointer, probably. I should check the docs, but fuck it. I don't want to. And this would be it. Box, leak, box, new, f, like this. So he actually doesn't like this for some reason. Oh, probably because I put an arrow where I shouldn't. And here we need to say if we found the create string. So we can say mode stir.find w. If we find that we want to write, then we're good. We can create. He wants me to use char, so sure, I can do that. All right. Okay. Hey, no iWAD file found. That's pretty sick. That's pretty sick. Look at that. Yeah, that's pretty sick. Pretty sick. So now we just have to try this. We just have to specify, well, we have the free doom wad kicking around. And so we can just inject that into this guy at the beginning. So when we say get or init, we're going to change this get or init. Instead of making like a hash map from nothing, we're going to say let ret is equal to hash map new. And then we'll just immediately insert something that we inject at compile time. So we'll say that the ret insert, I think it's free doom.wad is what they said. And the value will be, I guess, we'll have to let free doom bytes is equal to, he's going to be a U8 slice, and he's going to be include bytes. So just like embed this shit in my application. And I think it's in Doom generic right now. Doom generic. I think I had like a free Doom here. Oopsies. Free. And here, free Doom 1.wad. So we'll inject this guy into our binary and insert him as free Doom 1.wad. And we'll just have to copy this guy. So we'll say free Doom bytes to vec into box slice. He doesn't like that this is like the wrong path, so we have to go up a directory first, I think. Maybe up 2 directories? No, that seems fine. He's complaining about something, but I can't read it because it's running off the side of the screen, so we'll cargo check. And we'll look backwards a little bit. And oh, I have to make a box new spin lock evacuate. Gross. Okay, so this is not into box slice. That was only the path side. And here we say box new spin lock new. Okay, and then I return red. This guy does need to go to, or what's this guy? As bytes to vec into box slice. Look at that, beautiful. Love it when I have to like do these like gross call chains just to like use my API. That's like a good sign that my API is ideal, is having to put in like 4 calls just to use it. Fuck. Okay. So I guess I should be using static here. And yeah. Looks like it should now find freedoom, try to open it, and then fuck up on something else. Oh yeah, throwing a B in front of the string makes a lot of sense. To get one of the 4 calls out of there. Okay, so he actually still failed to read freedoom 1.wad, but it would be interesting to know why, because I think it should be in here. So maybe what we'll do here is we'll say the return value of this guy we will match him like this, but first we'll log him just to see. So we'll say printf, print line, fs open, and we'll log it. We'll just see what we get. We will see what we get. So even trying to open up free doom 1.wad, he got none, which is kind of interesting. I thought that we should get this. So let's double check what the path is. We should log that as well. So we'll keep the path string around so that we can log it. And we'll say, I guess we'll do the unwrapping here as well. And then here we can say fs open, we got this path and the ret. something's wrong. So let's just kind of move back up, look for the error. He's bitching that path is a U8 because I typed path, not path string. Oopsies. Oopsies, oopsies, and let's see what we get now. Okay, so he's saying, trying to open file, freedom1.wad. Freedom1.wad, none. Even though I'm pretty goddamn sure we inserted this right. Maybe I mistyped this. No, that looks pretty much the same. Oh, I'm an idiot. It's because I'm doing a read-only flag and I'm always returning none. But what I should be doing is I should be saying, well, if I am in write mode, I'm allowed to insert default. Otherwise, though, I just say files get the path. And then if I found it, I can map it to a file, and v. Sick. And I think now that should be the right type. This is an option of a thing. And if I found it, then we could return some, otherwise return none. I was also wondering why you didn't use w_no_error equals return type over to clean up the errors until you get around the additional functions. Because I'm fucking lazy. Is the right answer. You're right. I could do that, and then I wouldn't have to scroll past all of these. But like sometimes the like guy in my head is either like lazy in the way that I don't like. I'm way more willing to scroll up 100 times than type w_no_error return type once, which is like fucking stupid and wrong. But it's just like, you know, sometimes you just don't wanna. But you're right. That's better. But I'm still not doing it now out of spite. Because you called me out. Okay, so he found freedom1.wad, and now he's saying, well, fclose is unimplemented because he's trying to close the file that he just opened to check. So we'll just quickly throw in an fclose in here. So we'll look at fake libc, and we have fclose. And we will just remove him from here and stick him in here. And say, no mangle, please, because I want C to be able to call you and know where you are. We make an unsafe function because it's unsafe to interrupt with C. C is scary. Then we say strnc, because I think the strnc tells us the calling convention, and we say fclose. He returns an int, which is an i32 in our world, and he takes in a file star. Like this. I guess he's a mute file. Well, actually, yeah, mute file. Mutable file. And all he has to do is he just has to leak the file. So, because we're not actually flushing anything or doing anything like that, we'll just say box from raw f. And that leaks the point. That'll like clean up everything we want, and then return 0. Do I have a Discord server? No. Should I? I've never really seen the appeal of one. I don't really know what people would do on it. But if there's like a reason that I should have one, maybe it's a good idea. But yeah, as of right now, no Discord. Okay, let's see if I run that. fclose, should get past that? It should decide that it wants to open freedom1, and then when it tries to actually do something like fread it, it'll just like fail. Nice. Nice. So it looks like we're actually starting to parse the game, which is kind of neat. Let's get rid of some of these like stupid print lines here. And we'll kind of say that this is done. fopen, fclose. And now we're looking at actually reading and writing files. And I'm looking at the time, and that timestamp says that we're 1 hour 50 minutes into stream. So I think that if I were to go much farther, I would go over my like 2-hour mark that I'm shooting for. So I think we'll say that we'll do fread, fwrite, and continue on tomorrow. Yeah, thanks for watching, everybody. Appreciate you if you're enjoying the content. I guess I appreciate you even if you're not enjoying the content. But appreciate it. If you like what you saw, I stream most days at around like 1 or 2 o'clock Pacific time. And I stream for like 1 or 2 hours, somewhere in there seems to be a good amount of time for me. And if you want to watch live, we're on Twitch, but if you don't want to watch live or you missed for whatever reason, even if you did, there's a YouTube link in the Twitch description. There is a Twitch link in the YouTube description if you're watching on YouTube and you want to pop in, say hi, whatever. I'm going to post a link to the GitHub in Twitch chat, and I'll also post that in YouTube as the description as well, if you guys just want to take a look. What ends up in this repo is probably not what we're seeing today, because I usually will only push like more polished stuff in here, right? Like we will do some like prototyping on stream, and then I might do some cleanup after, like clean up the commit messages and shit. But if you're looking for like, how did I implement anything in here? The commit messages should be like pretty decent. These are bad examples because those aren't very interesting commits, but like, hopefully let's find like one good one. Come on, just one good one. Initially, yeah, like, so we know there should be like pretty decent commit messages explaining what's going on. So if you want to browse that, that's available to you. Yeah, thanks for watching. I'll catch you guys in the next one. Bye.